This video describes installing the ruby crystal in the MS-5000 ESR 5000 spectrometer. The tools that will be required are a 1.5 and 2.5 millimeter hex wrench, the front insert removal tool that come with the system, and then an 8 millimeter hex wrench which is provided with the ruby kit. This is the contents of the kit for the integrated reference ruby crystal. On the bottom here you'll see the ruby crystal itself with the ruby on the end of the stick. Also a cover plate to prevent changing or moving the orientation of the crystal. And then some covers to go on the top here to prevent access to remove the front protective cover from the instrument. This is accomplished by using the tool that came with the MS-5000, just this metal insert. And we just turn it lightly and now it comes loose. With the cover plate removed, you can see the small hole that the ruby crystal will go into. We'll want to make sure when we're putting the ruby crystal in that we don't bump the edges because it could cause the crystal to pop off the extension stick. This small little cube is actually the ruby crystal. This is just the extension stick to go and allow it access into the resonator chamber. As you're putting the ruby crystal in, the thing that you want to make sure is to not bump the edges and to go right directly into the hole. It's very difficult to see, so you want to use a good flashlight, and I know you can't see this so well from the video, but basically I'm looking to find the hole and rest the bottom of the crystal, or the bottom of the stick actually, in the hole, and then slowly push it in. Therefore I'm not going to bump the crystal off. Now I'll lightly turn it with my finger. The best way to describe inserting the ruby into the instrument is to mention that the bottom edge of this glass rod, notice the chamfer, will make it easier if this part of the rod goes into the hole at the bottom. And to kind of get that point across, I'm going to take this very large tube, even though the hole in the instrument's resonator is very small, and I want to make sure that glass rod with the ruby crystal facing up runs along the bottom part of that hole inside the resonator. I don't want to come in at the top because I could catch the ruby and pop it possibly off and lose it inside the instrument, which makes for a bad day. Also, to try to go right in the center is possible, but again, you have a very small hole and it's hard to see when your hand's in the way while you're putting it into the instrument. So I found that because of this chamfer on the edge of the rod, it's the easiest is to start by getting it into the bottom of the hole inside the resonator and sliding it in. 8 millimeter nut driver to slowly turn it to make sure it's in. What you'll notice, and you don't want to turn it too tightly, what you'll notice are two additional screws, hex screws, on the end of the ruby crystal. They're going to be used to go and allow me to turn the crystal's orientation, and then when I get to the correct orientation I'm going to lock them back down to prevent any other further movement. But during the time of adjustment I'm going to be using the 8 millimeter nut driver to go and make the changes. These are going to be very, very small changes, parts of a degree, to go and actually make it line up with the location that I need the main peak for the ruby to exist. In some cases, if you received your ruby after a factory acceptance test for Alanine, you may see two black marks, one on the nut itself and one on the base. Line those up initially as a starting point because this is what the factory found to be the best position for the ruby. Again, because the difference is so small, you may have to adjust around that black mark, or just depending on how it was inserted, it may change. But it's a good starting point. Here you can see the two black marks on the ruby holder. This is where you want to start by lining these up and taking your first measurement to see if it gives you the first indication of the ruby signal. So now what I want to do is loosen these screws up to allow me to turn the ruby crystal without tightening the main screw in too tight. So I'm just going to turn those maybe a quarter of a turn once they come slightly loose. And that's all I need to do. Now we're going to launch the ESR Studio software. This software allows us to take spectrum measurements with the MS-5000. The first thing I'm going to do is go to the recipe editor and load a recipe for the ruby. I've called one Ruby Fast. I've already created my recipe, but you can see the parameters. So I called it Ruby Fast in the recipe name. My magnetic field goes from 300 to 380 millitesla. I've set the sweep time to 10 seconds just to speed up the measurement process. and also set the modulation to 1 millitesla and 1 accumulation. And the power is set to 10 milliwatts. Once I've done that, if you've just created that recipe, make sure you do a save on it to not lose it. Then I'm going to come over to the main control. Now in my case, I've already taken some measurements to speed up the video, but in your case, you're going to want to go ahead and initialize the instrument to make sure that it's connected and communicating properly. As you can see in my case, I'm offline, but yours, once you've initialized, will go from initializing to idle, and at that point you're ready to take measurements. So now I'm going to go and put in Ruby as my file name, which I'll use to go and collect the first Ruby measurement. And at that point, I can hit start. And again, in this case, we're just going to do this offline. To give you a precursor of what the signal should look like coming from the Ruby, you'll see a small peak at the beginning on the left-hand side, and then a large peak on the right-hand side. The large peak should be somewhere around 344 to 348 millitesla. This will depend on the positioning also of the alanine signal that we'll see later. So here's my first measurement. You can notice that there may be some sort of sign of a Ruby signal showing up in this area right here, but it's still not conclusive. So now I need to rotate it very so slightly and take another measurement. If we're working with alanine, assuming we're around 332 millitesla for the alanine peak, the main peak, we'll want to make sure that our Ruby is somewhere between 344 and 348 to make sure that we're within the tolerance of the test. If we're using other material besides alanine, we can definitely put the Ruby center point at a different location. Now I'm seeing the Ruby show up, but the two peaks are too close together. What I'd like to see is the smaller peak further to the left and the larger peak to the right. Also, make sure they're not crossed where the larger peak is to the left. In addition, you'll notice that the peaks, instead of them going up first, they go down. This is because the positioning in the resonating chamber is 90 degrees, so we're seeing it go down first instead of it going up like you might normally see with alanine or any other material. Now that I've taken another measurement, I notice that the Ruby is starting to show more prominence as part of the background signal, but it's still not in the right location. So again, I'm going to take and rotate this very so slightly and take another measurement. So here's another measurement, and what you'll notice is the two peaks have shifted position. My larger amplitude peak, the main peak, is on the left, and the smaller peak is on the right, which is not what I want. So you adjust it again. Again, I'm going to rotate the Ruby crystal ever so slightly because I'm still not happy with its position. I'll continue to do this until I get the right position on the display. You can notice I barely rotated it. So now I have the Ruby showing up pretty much where I want it. The smaller peak is on the left, the larger peak is on the right. The larger peak is crossing zero axis around 345 or 346 millitesla, and this will be good as a first starting point. If I'm using this for alanine dosimetry, I'll confirm its location when I put an alanine tape tab or pellet in and verify that it's the correct number of millitesla away from the main alanine peak. If it's not, then I'll again make some small minor adjustments. Now I'm going to create a recipe called Ruby LongTerm. We'll use this for long-term Ruby testing if we're doing IQ measurements. We've set it from 320 millitesla to 355 millitesla for the sweep, the magnetic sweep, with a sweep time of 10 seconds, a modulation of 1 millitesla, with 1 accumulation, and a power of 10 milliwatts. And I've saved it away as Ruby LongTerm. Next, what I'll do is I'll come over to the main control, put a file name in called Ruby Test LongTerm, and you can name this whatever you like, and we'll take a measurement. Now I have my alanine signal from my tape tab. You'll notice several peaks, with the main dosimetric peak being approximately 331 to 332 millitesla. Notice also the peaks go first positive and then negative, and this is indicative of the sample being inserted in the top part of the resonator. This is the normal signal, unlike the Ruby, which will start off negative and then go positive just because of its 90-degree change in orientation. So I'm happy with this location here for the alanine signal. But what I can't see very readily is the ruby out in the far right, and this is just because of the auto scaling. When the software auto scales to the maximum value, it depresses the signal from the ruby just because it doesn't have as much of an amplitude. So what I will do is I'll come over here and use mouse zoom rectangle. I'll select that, and then when I hold down my left mouse button and make a box around that area where I see a small change in the signal on the y-axis, I can now expand that area, but still I'm not seeing much change in amplitude, only because again the scaling is still set from the Alanine signal. So now I'm going to come over to Y automatic zoom, select that, and now you can see the ruby very readily. So what I'll do is then look at where the ruby is crossing the axis, and I'll see it's 345 millitesla, and this is about where I want it given the placement for the Alanine signal. So I'm happy with this, and now I can tighten down the set screws on the ruby outside. If I want to go back and see the entire graph, I select X automatic zoom, and now I see the entire Alanine signal plus the ruby signal out in this area, but very depressed.
Once you're happy with the ruby positioning, then take the small Allen wrench and tighten the two outer screws. Make sure not to twist the center part of the ruby because that'll take and move the alignment out of position. Once you've tightened the screws, verify that the ruby hasn't changed position by running another measurement. If it has changed position, you're going to have to loosen the screws and start again. The other thing to mention is, if you're using the wrench with the smaller end going in, be careful not to drop it into the instrument. Once you've finished with the ruby positioning and tightening the outer screws, you can then go ahead and push this cap into position and then lock it into position with this center screw, and that'll prevent people from accessing it or causing it to be adjusted unintentionally. You can apply one of these little caps to the Allen screw hole right there to prevent an Allen wrench from being inserted. It's just a little protective cap that can be press fit in.
You've now completed installation of the ruby crystal in the instrument. You may have subsequent tests that are done, such as IQ and OQ as far as the installation requirements, but at this point the ruby is successfully installed. If you have any questions or problems, don't hesitate to contact us.